Welcome to Tropic Topics, and while we may not be talking about a traditional tropical system this time around, we are talking tropics at least somewhat. We've got a hybrid-ish type of low. This is tropical in origin. You can see the low down there in the Bay of Campeche. National Hurricane Center has even tagged it for a 30% chance of developing, but it only has today to do so. This is going to join that trough you see there, which will turn into a warm front and a cold front, and at that point in time, it's frontal bound, so no longer tropical, even though it may still have at least some tropical characteristics. It's going to have a ton of moisture with it, and that is the main concern. So regardless of whether we get some kind of low pressure system to establish down there, which doesn't look likely, it's pretty exposed, and not to mention you can tell how evident the shear is there by the other tropical system on the opposite side of Mexico, with all of the moisture and cloud cover being pulled across to our way too. So not concerned about this becoming any kind of strong tropical system, but certainly concerned about the rainfall that we're going to get, and it's much needed rainfall. We need the rain bad, so I don't think anyone's going to certainly complain about the rain, and we'll take it because it looks like a drier pattern is going to take hold after all of this rain comes through. But thanks for joining me on what is a special edition of Tropic Topics. We're going to go through this week's setups and hold on to those Hurricane Michael questions that you got for me. We're going to get to that. We're going to go through some of the photos that I took, and we're going to go through those. I'm going to try to explain them meteorologically, what you're looking at, and then what potentially happened for that photo to represent what it does. And we'll go through that. And if you have any questions that I can get to from that day or about Hurricane Michael or hurricanes in general, we're going to have an open discussion. We're going to try to do that. So you can put those questions, comments, concerns, wherever you're watching. We should be able to pull that up and be able to see those questions as to me, and I should be able to answer them for you. But we're going to go right into this week's setup, because first and foremost, we got to deal with now before we look at the past, right? So out there this morning, we fell down into the 40s. We climbed back up into the low 80s as expected. Cloud cover starting to work its way in, but it's mostly high cloud cover at this point in time. You can tell by the wind vector there over Tyndall Air Force Base, the wind has actually shifted to more out of the south and west, which is interesting because as the low pressure system develops, we're actually going to see our wind shift to back out of the east and northeast, which will bring us cooler air once again. And if you've been following along on social media here, we've been talking about a roller coaster week for the temperatures, and certainly that is going to be the case. So cloud cover streaming in now. Futurecast doing a good job of that. Probably dry overnight tonight, but by the morning hours tomorrow, we'll see the shower activity start to work in. Initially, the radar is going to be busy, but we're not going to have rain at the ground. That's because there's so much dry air in place as this starts to work in that we're actually going to evaporate that moisture, which does have a consequence. When you evaporate moisture, you are pulling heat out of the air. It's called latent heat process and wet bulbing. So our temperature will actually drop. Once the rain starts to move over the top of us, we're going to see our temperatures go from the low 70s down into the low 60s, where we will then stay the rest of the day because we are going to be absolutely wedged in. So tomorrow is the quintessential washout type of day. Sorry if you got plans tomorrow. It's going to be raining most of the day. The morning hours might be the only dry time that you have. As we get into the evening hours, that's when the heavier rain setup comes in, and these convective style type of storms will be working in, but they're going to be working over dry, cool air. So these will all be elevated. There's no severe concern until we get into the late night hours, say about 2 a.m., and you can see the wind vectors there start to lift up. The only place that destabilizes in this scenario, if the warm front lifts that far north, is Gulf and Franklin County, southern Liberty County. Those would be the only areas where we'd be concerned about severe weather if it played out like this. Now, I think we're probably going to see the warm front stay offshore, probably attached to the shelf, and we'll likely see all of the stronger severe storms stay on that warm front boundary, which will stay over the water. But from 2 a.m. to about 6 a.m. on Thursday, there will be a narrow window right along the immediate coastline in Gulf and Franklin County where waterspouts moving onshore will be possible. So tornadoes will be possible in those counties, mostly the coastal areas, which is where our population lives in those two counties. So would be aware in both Gulf and Franklin County, there is the possibility of severe weather as we go into tomorrow night if the warm front lifts ashore. And that's a big if. I think most likely we're going to see it set up like you see here, where the warm front is just offshore. We get wedged back in, so the cooler air comes back to us Thursday morning. But watch the wind vectors here. They'll start to creep up. And in this case, by the afternoon hours on Thursday, our inland areas, say Mariana, probably still in the 60s. Our coastal areas, Panama City down to Apalachicola, Carabel, probably in the mid-80s. So we're going to have tight gradient across the area from inland areas along I-10, nice and cool Thursday afternoon, to very warm and humid along the coast. But don't worry, everyone gets in on the action of the warm and humid as we go into Thursday night and Friday, because that warm front lifts entirely through the area. And by the time we get into Friday, we're talking about much, much warmer temperatures. So Thursday and Friday, especially along the coast, are going to be warm and humid after a cold, windy, wet day on the way for tomorrow. So here's the warmest temperatures we're going to see on our Wednesday. Note 9 a.m. and we're about 73, 74 at the warmest. Rain starts to come in, and watch the temperatures drop down into the low 60s by the time we get into the afternoon and evening. And then right here, there you see the warm sector moving ashore, because you can see Apalachicola sitting at 76, while Panama City is at 63. So the areas that warm up, that's where the instability is going to be, and that is only Southern, Gulf, and Franklin counties. So that's the area where we're concerned about the potential for severe weather. And again, that's going to be late into the overnight hours, and it's really only from about 2 a.m. to about 5 a.m. So it's a very narrow window. And then we get into Thursday, and here's what I'm talking about. 71 in Mariana, but 84 in Panama City. So there's going to be a drastic difference on what side of the wedge you're on when we go to temperatures on Thursday. Rainfall amounts have come down just a touch, but with convective activity, you can easily double any of the numbers you see here. So I think 2 to 4 inches of rain is probably the upward bound of what we're going to be seeing, but isolated areas of 8 inches plus will be possible. That means flash flooding will be possible, and flooding in general will be possible, but it's been so dry that unless we have heavier convective rain falling over the same areas, we'll probably see a lot of this just run off and go into the ground. I know with dry conditions, you really get runoff to start first, and then the ground becomes saturated, and then you start to soak it in. So when you're in drought, you actually want like a light drizzle for like 5 days. But you don't really want a heavy rain, because the rain doesn't go into the ground, it just runs off, because the dryness of the ground actually acts as a barrier to let the water actually seep in. So if it's raining too heavily, it just runs off. That's why flash flooding happens a lot in drought. And we are currently have drought from the central to the western half of the area. So there is some concern for flash flooding, but in most cases, this is just going to be absolutely needed rain. And you'll see why, because after we get done with the rain Friday and Saturday, we bring back the cool, dry air. So this is how it should play out. Warm front starts to lift off to the north, but you see the heavier rain right on top of us. I think the warm front stays offshore, but there's that little section there that could clip as it goes across Franklin and Gulf counties. By Friday afternoon, you see the temperature there behind our frontal boundary. It's reading 89 on the model. I don't think we're going to get there because we'll have cloud cover around, but we certainly could be in the mid-80s Friday afternoon, warm and humid. But don't worry, the cold front is right hot on its heels. By Saturday morning, cold front's right on top of us. That clears us out, and then we see the cooler air come in. So Saturday, even though we're going to climb into the mid-80s for the daytime high Saturday, our air is going to feel much, much better because dry air will be in place. And then Saturday night, guess what? Headed back down into the 50s. We'll only climb into the low 70s Sunday. Upper level low parks itself across the northeast, which brings a wedge down the east coast, as well as the upper level ridging, helping to bring cooler air down from Canada. And guess where the coldest spot in America for below average temperature is going to be over the next 6 to 10 day range compared to average? You guessed it, the Deep South. And for that matter, the Deep Southeast. So going from Panama City, Jacksonville, Atlanta, Charlotte, down to Tampa, that has a 100% chance of below average temperatures in the 6 to 10 day range. So yes, the cooler air is coming back. We're going to have a couple of days of warm and humid, but the cooler conditions are going to win out here and win out in the long range as well, because we're headed into fall. So as we look at the timeline for our Wednesday here, through the morning hours should just be showers. We'll transition about midday from showers to a consistent rain. And then as we go through the afternoon and evening, that's when rain is heavy is possible. And the low low risk for severe weather there really is going to be between 2 a.m. and 5 a.m. I did include low risk all the way until about 7 p.m., but in general, that is going to be offshore. So note the temperatures there. We climb to the mid-70s by the mid-morning. We fall into the low 60s in the afternoon, and then we'll see the temperatures climb as we get into Thursday midday as the warm front starts to lift back off to the north. So most of the area is just looking at rain out of this setup, as well as, breezy conditions. Northeast wind 10 to 20. East-northeast wind 15 to 25 in the afternoon hours tomorrow. Gusts could be as high as 30, maybe even a couple of sporadic 35. So not only is it going to be in the low 60s, it's also going to be windy. Oh, and by the way, it'll be raining pretty heavily as well. So, it's not going to be a great day to be out and about, especially in the afternoon and evening tomorrow. So if you had to get things done, I suggest doing them this afternoon because that's when you're going to have the best opportunity to do so. Thursday is not going to be a wash, so if you've got plans and things like that on Thursday, we'll just have some showers and pop-up storms around. Same thing on Friday, just some pop-up activity, and then the drier air should start to come in and clear out that moisture as we go into Friday afternoon. So as of right now, unless we get so much rain that we flood the football fields, I really don't think that we're going to see any kind of delay in any kind of football games or anything like that for Friday or any outdoor activities Thursday and Friday. Probably fine as long as you can deal with a wet ground. You're probably okay. Saturday, you're going to be golden, but will be warm. Temperatures will still climb to the mid-80s. It's still better because the dew points will be dropping, but it will be very warm on Saturday. And then breezy and much cooler for our Sunday, and we'll have that cooler air come back around. So moving on, we're going to go to Hurricane Michael now. So we're going to talk about all those questions that you may have about Hurricane Michael. You can throw those in the comments section wherever you are watching, and we're going to get to them. I'm going to go through quite a bit of little things here or there, and we'll go through your questions as well. I've had some great questions asked on my social media already that I have answered there, and we're just going to go through these, starting off with the pressure-wind relationship. So to most people's knowledge, majority of the data collection out there was gone peak Michael. And yes, that is true. So what I have here is actually a professional wind gauge that was mounted to the Hathaway Bridge. So that's where all of this data is coming from, is from the Hathaway Bridge as Michael worked across. So you can see that the pressure dropped all the way down to like 943 at the Hathaway Bridge. You can also see that the peak wind speeds, sustained wind speeds there, around 120 at the Hathaway Bridge, which makes sense based on the damage that we saw around Bay County. So what I want to highlight here really is not the peak of anything, but it's the pressure-wind relationship. So you can see as the pressure, the green dots, drops, the wind goes up, and it's almost an identical inverse. As the pressure starts to rise, the winds drop. So whenever we're talking about why does pressure matter, why does the lower pressure, why are we always talking about pressure with tropical systems? Well, pressure is directly related to wind. In fact, they're correlated. Your pressure is what causes the wind. The difference in pressure gradient between high and low is what causes that wind. And the greater the gradient, the stronger the wind is going to be. And in those extreme cases, we see that in downsloping events and hurricanes. Those are your extreme cases of a pressure wind gradient. So if you've ever seen a historic downsloping event, you can see wind speeds 150 miles per hour on downsloping events, and you can see forests just completely disseminated from downsloping events as well. They're usually much, much smaller, but they show you the microscale capabilities of this pressure-wind relationship when you look at those downsloping events and elevations. But for us, it's obvious in tropical weather with hurricanes. So this is a photo I took at the Weather Center of the computer as we had the satellite pulled up while we were doing live coverage this day 5 years ago. And the reason I took the picture is because it just absolutely shows you the stadium effect so well. You can see the cloud shadow on the south side. You can see where the sun is hitting the northern eye wall and going all the way down to the water where the clear eye was as this was just about to work on shore. And if it's not obvious enough, let's zoom in. And now you can really see the stadium effect here. So it's the bowl shape that you get. And yes, this is a satellite image from Hurricane Michael. There's quite a few things that you can point out here on the weather side. First, the stadium effect. Second, you can see kind of little mini swirls in the eye wall itself. Those are the mesovortices. And when you look at the clouds around the eye wall, note all of the ridges and bumps in there. That tells you just how violent the updrafts were, that you're still getting all of those knots and ridges. They're basically the same thing as when you're looking at a cloud in the summer and you see a cumulus cloud building. The tighter the notches and ridges in that cumulus cloud, the stronger the updraft is. So the more notches you see in the cloud on the top, especially on cloud tops, the stronger that updraft is. And in case of Hurricane Michael, we had periods where we were getting cloud top temperatures at minus 180 to 200 degrees Celsius. Yes, you heard that correct. Minus 180 to 200 degrees Celsius. That was the cloud tops. That tells you how violent those updrafts were, because they were going all the way up and reaching way up in the atmosphere to those extreme colder temperatures, and still they were rising, which is just crazy to think about. But that's the kind of violence that we have inside of these super strong hurricanes like this, is that you get that kind of updraft capability. And I think one of my favorite questions that I get asked is, well, how could we stop these? Is there any way we could just nuke them or something like that? That's my favorite question, is when someone says, let's just nuke the hurricanes. Not only would it not work, it would then create a massive radiation downfall and with the hurricane coming inland. So you would not only have the hurricane to deal with, you would then have to deal with the radiational fallout from the nuke in the hurricane itself. So the equivalent of a Category 5 hurricane is hundreds of nuclear weapons. Hundreds. Not just one, it's hundreds. So that's why if you dropped a nuke on it, it would do nothing. It wouldn't even disrupt it. Wouldn't even notice. It would just spit it out, and then you'd have to deal with the radiation. So that's why that is always funny to me, because people just don't understand the scale and the power of what these engines, because that's what they really are. They're atmospheric engines, what these things can do in the atmosphere and how much energy they actually have. So that's always my favorite question. But to drive home the stadium effect even better, this is not my photo. This was actually sent to me from Callaway, and this was inside Hurricane Michael's eye, so you can see the stadium effect very clearly there, with the sun shining right through the middle of the eye wall, with that cloud cover just towering over the top. So what's crazy is I took this screen grab from a video that was sent to me, and in that video, all you hear is birds. It's dead quiet, and all you can hear is birds. And it's because birds were trapped in the center of the eye because they had flown through the eye wall and they got into the calm, and then they didn't want to go back through the eye wall, so they just follow the storm inland until the storm collapses and the eye wall collapses, and then they're basically stuck with wherever that is. They'll just hunker themselves down at that point in time and ride it out like any other animal does. So the birds, it's quite eerie when you do watch that video, but because that wasn't mine, you just get the screen grab, and so that's all you got there. So a little bit to our story. We obviously wrote it out here in the station, and when we were in the studio, the reason, if you watch any of that old footage, you can see that obviously we're stressed, and it's more so than just the storm itself that was ongoing outside. We could smell gas in the building. We also could feel the building shaking because of that, what you see right there. The roof from the church next door to us here actually landed on top of portions of our roof, and we were completely unaware until after the storm went through. So every gust that came in would lift up that metal, and it would slam it back down into the top of our building, and was punching holes in the top of our building as well. And so we were at rain coming in, and we're smelling natural gas, and we're wondering what the heck is going on. And we obviously can't leave the building. So while we were on air, all of that was happening in the background, and the light grid was shaking, and that light grid never gets cleaned. So you just had dust coming down from the ceiling as well. I think after Michael, I walked back into the studio, there was probably about an inch of dust on top of everything inside the studio. But by some kind of miracle, the studio and where we house all of our electrical equipment were the only two rooms that weren't really damaged in the studio itself, which is why we were able to basically refurbish and come back and get back on air much faster than we would have thought, because we got really lucky, and the two rooms we needed to not be damaged didn't get damaged, which is just an absolute miracle if you ask me. But that's a little bit about our story. This is my photo as well, and I will contend that this might be the best photo I took, and I took hundreds of photos. And the reason why, it's because it's not what you see that's obvious here. The damage from the wind blowing the roofing material off of the church, and then you could see those industrial-sized air conditioners sitting there right in the middle of the street on, what is that, 98, right? Right here, Harrison crossing. That's 6. Is it 6? Yeah, it's 6. Okay, so it's right here in downtown, right by First Baptist. And you got those industrial sites, and those are all eye-catching, right? But what you're probably not paying attention to is look at the power pole. Look at the bottom of the power pole. You see the big hole around the power pole? That is because those power poles were shaking so violently back and forth that all of them created holes in the concrete like that. That tells you the power of how bad those things were shaking back and forth. So even places where you didn't have the power line snap or break, which was the majority of the area, you still had massive holes from the poles themselves just vibrating back and forth during the storm. So that one is always mind-blowing to me. This photo has obviously been shared thousands, maybe millions of times of Jinx Middle School here where the walls are blown out, which, you can kind of tell why. If you see the support beams here are both on the east and west wall, and there are no support beams on the north and south wall. Well, where was our strongest wind in Bay County was more or less out of the north and east. So this was one of those cases where you had strong wind and strong pressure pressing on a non-load bearing wall, and the wall gave out. And then once that gave out, the other wall gave out. So that's a good engineering look and study right there. This is the photo I posted yesterday, and it is a picture that I took on the way to Mexico Beach about 2 days after the storm. And what's really interesting here is you can see the storm, or the trees are folded in opposite directions. And if that's not fun enough, the power pole, it is pulled forward. So the reason that the power pole fell forward is it's likely that the power pole fell from tension down the line. So it's likely that going toward Mexico Beach, that those poles failed, and then everything down the line dominoed and failed down the line, and that's why it fell off to the north as opposed to the direction the trees are leaning, which is east-west. So the tension of the line itself actually pulls that off to the north. And the reason those trees are hatched is because this is the place where Michael made landfall. So this was direct, centered up, teed. So you have an east wind on the north eye wall, you have a west wind on the south eye wall, and thus the trees hatched, bent over in opposite directions. So that's how you get that, is that tells us exactly where the center went, is where those trees are hatched. So you don't even need to look at the radar data or know any of that. You can just look at the ground damage to know where the storm went as well. Mexico Beach, obviously devastating. The majority of the damage here, water, storm surge. This is case number 1 of 4 billion of history's examples of why you run from water. Anytime we're talking about storm surge coming in, because storm surge is unsurvivable. Wind, if a tree doesn't fall on you or your house holds up, you're going to survive the wind by just hunkering down. I mean, we've got proof of that, right? But Mexico Beach, when you get storm surge and your home is sitting at 4 feet, and we're talking about inundation of 14 feet, this is the result, is that it's gone. So that's why we always are stressing about storm surge and talking about the water, and then we kind of highlight the wind on the backside, because the wind is survivable most cases. The water, not survivable, and that accounts for the majority of deaths in all tropical systems is, unfortunately, storm surge and people that just decide to stay in a storm surge area and then get trapped and it's too late. Thankfully, the majority of the people that were at Mexico Beach left the morning of. So there weren't that many fatalities in Mexico Beach. There's only 4 fatalities that I am aware of that happened during the storm in Mexico Beach. Sad enough as it is, but much better than the 300-something plus that we were told that had said they were going to stay prior to the storm. So after the storm, it was quite a surprise to find out that the majority of people left in the morning hours before the storm actually made landfall. So that was great news when we went down there and did the coverage. And obviously, a much better situation than the inverse. And then this picture is always just it always is just a staggering one as well. This is the power outages you can see from space, and it shows you just the scope of how far inland we knocked the power out. So that's Albany, Georgia there, right on the yellow line and on the northeast side. And you can tell it is pitch black from Panama City, Apalachicola, Port St. Joe. I mean, there's no light in there. None. No light. And this was on October 13th. So we're 3 days after Michael, and I think it was probably the first time that we got a clear night cloud-wise, so they were able to do this scan, and you can tell just the scope of the damage of what Hurricane Michael did. So if you got any comments, questions, or anything that you want to throw by me, I've been keeping an eye on my stream here, but I'm not seeing a whole lot of questions. So go ahead and throw those in there. I think I've got a couple of them. I see a couple of questions about our current setup. Do you got anything for me, Spence? Well, I was expecting people to let them rip on the questions. Maybe I answered everything. I kind of doubt it though. Everyone's just learning. So if you do have any questions, comments, anything like that, I'll give you a few minutes to go ahead and start to chime in here, and we'll try to answer a couple of those questions. If not, then we'll wrap up here relatively soon, and we'll get prepared for a very wet day tomorrow. I do want to say that I consider myself extremely fortunate for how things played out in Michael and my situation. I was living on the west end of the beach at the time, so I got really lucky there and didn't have a ton of damage. And then during the storm, my wife was away with the dog, so I wasn't all that concerned about her safety or well-being because she was taken care of. So I was able to kind of go through the storm basically just as a meteorologist here, which was far different than the people that were here at the time that lived here because they were dealing with their family, their homes, and all of those kinds of things. So I really do consider myself and my situation and how that played out a really, really fortunate for what happened to me and with me during that time. But I have also been able to process a lot of this because I've been forced to. I know that this is an extremely difficult day for a lot of people around the area because you're replaying the memories. And then you got people like me who want to throw the radar up and show you what's going on or want to pull up old pictures and talk about them. So I've had the ability to be able to look at all of this data, understand what happened, and process that information. And have had my dark times from the storm. I don't think anybody that went through it, it wasn't changed in some kind of mental capacity or form or just your outlook in any general way. I think everybody that went through it, especially was in the eye wall and had to deal with that, you've changed somehow or some way from that storm. I certainly did as well. But thankfully, things did work out. And I want to say that what happened in that storm and however you did go through that storm, it should show you the resilience that you have because we went through that and now we're here, right? So it should tell you that you can go through absolute catastrophe, you can rebuild, you can survive, and you can create again. So that should provide some strength and some help to today because we're here, right? We made it. We've recovered somewhat. We still have a long way to go, obviously, because we've got FEMA projects still ongoing. We've got things that we still need to take care of, but we certainly have improved far greater than I expected in 5 years. I thought it would take 15 years to look like it does now. And so I am immensely grateful for all of the individuals that what they have done to get to this point in 5 years as well. So just hats off to the community and hats off to all of you guys. I went through it with this at the station, surrounded by a bunch of people in a relatively safe environment. I can't imagine going through it at home alone or a place like near the springs, because I drove up near the springs after Michael. I tried to drive around the whole area I wanted to see and survey as much damage as I could. And I can't imagine being down a dirt road up there by the springs with all of those trees that we had before the storm. And I can't imagine what you were thinking or processing or having to deal with up toward Bayou George, going over toward Econfina, all of those places that are relatively rural in our county that are hard to get to anyways. That day were impossible. And then days afterwards were impossible. So, hats off to you guys, because I don't know how you did it. So, I mean, give yourselves a round of applause to go through that and then still be able to recover. So, I think today really should be not a day that you're looking back and depressed about. I think it really should be kind of a day that you kind of are able to look back and go, wow, look at what we did. Look at where we came from. That's kind of the way I try to process it anyway. So, if there's no questions, we'll wrap it up right there. Let's see here. I do see one. Maslina Bayou, but the lowest pressure we had was 2741. Yeah, I actually took a picture of the pressure gauge here at the station, and we dropped down to 27, which is close to the Labor Day storm, which is just crazy, but it makes sense. I mean, Tyndall's not that far away from the station, and the pressure recorded there was 919 millibars. So you're talking about a top 5 type of pressure event on a storm. Obviously not the highest wind speeds ever recorded in a hurricane. We've seen Dorian in 2019 was 195. So that's at like the top end of the scale. Wilma got up to 205. Patricia got over to 207, which sets the record. So you've got stronger wind speeds out there, but as far as a landfalling system at pressure, it's a top 3. And then as far as wind speeds at landfall, it's top 20. So we're talking about one of 4 category 5s to make landfall. Certainly a historic storm that should be remembered in the top tier of hurricanes. So good question there. You got one for me, Spencer? Did not live here during that time. How did it go from a 2 to 5 so close to landfall? So that's a great question, Kevin. So we had a couple of different things just go absolutely wrong for us and absolutely right for the storm. The first one is that earlier in the year, we had Alberto to start the year in 2018, and then we had Gordon following Alberto about a month later. People always forget about Alberto and Gordon because they didn't really do much other than cause surf and rain across our area. But Gordon dropped quite a bit of rain across the Panhandle and even well inland. Well, Gordon was then followed by a heat wave through August, and our temperatures were very, very warm. So the coastal waters, when Michael came in on October 10th, should usually be around 80 degrees. They were about 84, 85 when Michael came through. So that played role number 1. Number 2 was the forward speed of Michael. So typically hurricanes in the Gulf of Mexico, they kind of blow up in the middle of the Mexico because that's where we've got the loop current. That's where we're closest to the Caribbean warm waters that's being pumped into the Gulf of Mexico. So that's usually where you see the highest strength come from out of Gulf hurricanes. Well, in Michael's case, it was moving so quickly that, yeah, it organized and rapidly intensified there. But in the last 24 hours, Hurricane Michael went from didn't mean to hit the mic there. Went from a 115 mile per hour storm, so a category 3, to a 160 mile per hour storm. That's a 45 mile per hour wind increase in 24 hours. And that is all thanks to the forward speed. So all of that water that should have been upwelled to the shelf and cooled down didn't happen because Michael was moving so fast that it never upwelled any water to the shelf. So when it was running over the shelf, it was still running over 84, 85 degree water. So it rapidly intensified all the way through landfall. And if you go on my social media, you can actually see that I posted the radar right up to landfall and just before the landfall. And that is still to this day the most mind-boggling radar I have ever seen, because we had like 5 mesovortices inside of the eye at the exact same time. And they were rotating around so fast that it actually, if you look at the center point of the radar data, it looks like the hurricane was spinning in the opposite direction because the mesovortices were rotating around the eye so fast. They kind of smoothed out, and then the eye wall contracted right as it was coming ashore. So that contraction only happens with the highest end rapid intensifying type of storms. So you had everything go right for the storm, and you had everything go wrong for us. Michael peaked right at landfall. That was the strongest the storm ever was. If the storm had stayed over water for probably about 8 to 10 more hours, we likely would have seen an eye wall replacement cycle, which is exactly what happened with Idalia in the Appalachia Bay. It did upwell water because the way the Appalachia Bay is pointed, it pushed cooler water up there, so it was running over colder water in the Appalachia Bay, and then it went through an eye wall replacement cycle right before landfall. So that storm went from a Category 4 all the way down to a very relatively manageable 3. But the issue here is that regardless of where they peak, you either are dealing with winds or you're dealing with storm surge, right? So Katrina is the opposite effect of that. Katrina was a Category 5 in the middle of the Gulf of Mexico. It upwelled that cold water to the shelf, made landfall in Mississippi as a Category 3. Most people think it made landfall as a Category 5. It didn't. It was a weakening and falling apart 3 as it made landfall. The gusts from Katrina are not impressive. We only had a highest end wind speed in New Orleans at 90 miles per hour. You only had 110 mile per hour wind gusts recorded in Hattiesburg, Mississippi, and Meridian, Mississippi only got up to 120. So the wind speed's not anywhere close to what you had with Michael, and in fact, much less than 120. So it was only around 100 in those locations. But the issue is that all of the storm surge was created when it was a Category 5 in the middle of the Atlantic. And so even though it was weakening as it was coming ashore and the wind damages weren't that bad, it had 28 to 30 foot of storm surge, which still holds the record for landfalling storm surge in the U.S. So there's a consequence no matter when the storms get strong or how they come ashore. You're either dealing with wind or you're dealing with water, whether the case is water from rain, like Sally, or water from storm surge, like Katrina, or wind, like from Michael. So it really never is a good situation when you're talking about a major hurricane, period. That's kind of why we always stress. Major is major. If we're forecasting a Category 3, don't ask me if it's going to be a Category 5. It doesn't matter. You're still going to be talking about major devastation and major consequences. Idalia, look at all the storm surge issues that we're still dealing with, minus the wind that even happened in Perry, Florida as well. So you've got the wind damage, you got the storm surge damage. That was a weakening Category 3 that made landfall there, but it did get up to a Cat 4 beforehand. So you built that storm surge as the storm is building in the middle of the Gulf. So that's why I always try to stress, every storm is different. Every situation is different. Focus on the impacts and don't be all that concerned about category, because category really just doesn't tell the story, right? Because again, most people think Katrina was a 5 when it made landfall, and it wasn't. It was 3 and a weakening 3. I vividly remember watching the coverage of Katrina coming in. Actually, one of my heroes who's in Charlotte, Brad Panovich, was in New Orleans at that time, and I remember watching his coverage in New Orleans as that was unfolding. So, so that's a great question. I hope I answered it. Probably went way over and beyond what you were asking. Do we have another one? Okay, I thought I saw... let's see here. What was the pressure gradient? That's a good question. I'm not quite sure. Over distance, I'm not sure what the pressure tendency there was, Tyler. So I'm probably talking a little too fancy for people, but I know Tyler knows weather, so he'll probably understand what I'm saying, but I'm not real sure. I'd have to go back and look at it. You could probably do the math yourself, to be honest, if you wanted to. So just answering the questions as I'm seeing them. Let's see here. Okay, well, I think that's it. I don't see any other questions, so we'll wrap up from here. But make sure to tune in tonight at 6:30 after the newscast, because we will be airing an oral history of Hurricane Michael from first responders and individuals around in the community that were here during the storm, and some perspectives from those that weren't here during the storm as well, that are from the area that are to that as well. So I've seen bits and pieces of it. It's really good. If you're an emotional person, it's probably going to make you cry. Just FYI. But it's really, really good, and it's definitely worth the watch. So tune into that. That's at 6:30. And of course, 5, 6, and 10 tonight, we'll be talking about the setup for what we've got going on out in the Gulf now and the heavy rain setup for the day tomorrow, and then just the wild weather swing that is going to be warm and humid to cool and dry as we head into the weekend and going into next week as well. If you can always check out the latest from mypanhandle.com/weather. We've got a bunch of great tabs on there. Spencer and I put a ton of effort into making that way, way better. So go visit it, make it useful, because it is useful. And if you don't have the Storm Track 13 app, shame on you. I'm just kidding. You might be new to the area, so download the Storm Track 13 app. It's a great thing to have as well. You can get it on the Apple Store or the Google Play Store. It gives you a ton of information that is way beyond what we can cover as well. And really, you can be your own personal meteorologist with that app. We've got tracks on there. You can pull up the hurricane models. You can pull up the future cast. You can pull up future precipitation, future rainfall totals. You can look at the radar real time. You've got lightning updates. You've got lightning notifications. You got severe weather notifications. The Gambit just runs it. And again, it is really a very useful app. That's not just me patting corporate on the back, but it really is a very handy app. And again, Spencer and I have done a lot of work on that app too to make it better, including what I always get asked for is a specific location forecast. And guess what's on there? A county by county forecast. So you can go and look, and it's even split between coastal and inland for our counties that do have a coastal and inland. So if you're wondering, you can go and look at your inland forecast specifically for your area over a 3-day period that's going to be much more fine-tuned to your spot than what we're doing generalized on the news, because obviously our coastal area extends from Walton County all the way to the very eastern tip of Alligator Point. So obviously the weather on the eastern tip of Alligator Point is not going to be the same weather as you go out toward when you get near Sandestin and Destin. Like, they're not going to have the same weather routinely. You're going to see some kind of differences between them. And the same thing is true from basically inland Franklin County to northern Walton County. You're going to see different weather too. So the weather runs the gambit, and our weather forecast is literally generalized for that 9 counties because it has to be, right? There's no way we can go specific. So that's why you see the differences in that. But you can look specifically, but you have to do it. And it's on there for you, county by county. So that's in the app as well. And you can check out always, get the latest from my social media as well as mypanhandle.com. But that's going to do it for now.